Hey everyone, we are in 6.3. This is page 80 in our packet, and we are looking at solving. So before we start with this solving, I want to remind you, because we're going to be solving log and exponent problems, and I want to take you back to our last chapter and how we did some of the solving problems. So for instance, a problem that was similar to what you had on the test, okay, was you might have had 2 to the x plus 3 power equals 8 to the 5x power, just making this up. And so the idea to solve for x is you would need these bases to be the same. So we're looking for a base that can get us to 2 and a base that can get us back to 8. And again, you have this exponent table that will tell you 2 can get you to a base of 8. So what's going to happen, here's my wall, this one doesn't have to change, and I'm going to rewrite 8 as a base of 2. So 2 to the what power makes 8, and that's a third power. And then I'm going to take the original exponent, and I always just put it in parentheses, because I want you to see this as 8 to the 5x power. And then once those bases are the same, you can ignore the bases, and the exponents can become your problem. And then it's more basic math that you did in middle school in your freshman year. So first I'm just going to multiply these. And now to solve for x, I'm going to subtract this x over. That gives me 14x. And then to solve for x, I divide by 14. And that's going to make x equal this fraction. All right? So let's try another one like that. So let's do 4. 4 to the, let's just make it 4x power equals 1/16. This is a challenge. To the, let's make it an x plus 7 power. I'm just totally making this up. So remember, this just comes from a negative exponent. So what I want to do is find a base that can get me to 4 and 16. So there are actually two choices, but I'm going to give you the simplest choice. The simplest choice is just to leave this as a 4. So this will stay as 4 to the 4x. And then I know, so 4 to the what is going to make 16, because I just know that it's a negative exponent that will make the fraction. So 4 to the what power makes 16? Well, that's 2, but then a negative 2 made it into the fraction. And then I'll take my original exponent and put it in parentheses. And now once the bases are the same, I can ignore those and focus on my exponents. So here to solve, first I would just distribute my negative 2 in. And then to solve for x, I'm going to add this 2x over. And now to solve for x, I'm going to divide by 6. And when I'm done, I get this fraction, which I could simplify if I want. I could turn it into a decimal. That doesn't really matter. Okay? So that's what we did. But now what's going to happen is we are going to run into problems where I'm going to ask you to tell me 2 to the what power makes 11, for instance. And the only way we're going to be able to do this, besides using the graphing calculator of our feature of our calculator, because we did that too. So what we did is, sorry, I'm just getting there, is we would have put 2 to the x, and then the other side in, we would have graphed it and have seen where these two meet. So I will have to adjust the window here, and this is a little hard to see. So here's 2 to the x graphing, and you can't see 11. I'm going to have to adjust the window here in just a second. So let me adjust my window. It's going, it'll be there. And then we would have seen where these two meet by doing second trace, choosing option 5, and moving that cursor close to where they intersect. And whoops, and I already messed up. So whoops. So second trace, intersect, and now hit the enter button 3 times. And we would have gotten this, it's maybe hard to see, 3.460 when I round, okay? So what we're going to do is look at how we don't need a graphing calculator to help solve, but just any calculator would help us solve, all right? Okay, let's get started. So let's start here. Let's look at the 2 different ways we are going to be able to solve these problems. So now, what I want to ask myself is, can I get a common base between 2 and 4? I sure can. I can make a base of 2. So one way I can solve this is to use what I already know. So here's this wall I like to draw. So the common base between 2 and 4 is 2, so I'm going to leave the left side alone. And I'm going to make 4 into a base of 2 by doing 2 to the second power. And now when my bases are the same, I can ignore them. And the exponents become the problem. And to solve for x, I'd simply add the 1 over, and I would get 3. So there's another way to solve them, because you won't always be able to get the same base. So let's take a look at that one. Well, actually, let's do this problem first, and then we'll come back. Sorry. So here, I want to make this problem look like this one. So I need to isolate my base and exponent. So I'm going to subtract my 2 over. And that's going to give me 64. And then I would use my exponent table. Can I get 4 to have the same base as 4 and 64? I can. So I can get this to stay as a base of 4. And then 4 to the third power is 64. So I haven't changed the problem, I've just changed the way it looks. And now when those bases are the same, I can ignore them, and I'll have the exponents become the problem. And from there I could add 3, which I'm running out of room, so that would give me 6. And then I could divide by 2, and my answer would be 3. So there is a way to solve them if you can get a common base. But if you can't get a common base, then we have to use this idea of these inverse properties. So I wrote some stuff up here, just ignore it. And what you need to remember is that if the base of your log is the same as the base of the exponent, then the base of the log will cancel out the base of the exponent, and what you have left is your answer. Or I can write it, if I have an exponent problem, and in that exponent is a log, that this base can take out this base, and what you're left is what you have. All right? And that is how we're going to be solving for logs. So we're still going to do this whole thing of like trying to isolate x and get x by itself. So we're going to work backwards in the order of operations. So let's start here. So when I say work backwards in the order of operations, adds will have and subtract will be inverses. Multiply and divide will be inverses. Exponents will now have a log as inverses, and then we'll deal with the parentheses. So my first thing I want to do is, so here's the problem again, is in the end, my goal is just to have, since it's an exponent problem, the base and the exponent. So I would like to move some things out of the way, but this is the base and the exponent, so I don't have any addition or subtraction to move, and I don't have any multiplication or division to move, because I just have the base and the exponent. So what I'm going to have to do now is to undo this exponent is I will be making a log. So what I'm going to do is this. To undo the exponent portion, I am going to make a log, and I'm going to write the word log first. And this base is going to determine what my base is going to be, because I'm going to undo the exponent. So to undo an exponent, I'm going to have to make a log. And again, this base will determine what this base is. So I'm going to make a log with the base of 2, because that's going to cancel this exponent base of 2. And then this is just going to go right here. Okay? And remember, whatever I do to one side, I have to do to this side. So this side, I'm going to do the same thing. I'm going to put a log base 2, same thing to same thing, and I'm going to put the 4 behind it. And I know this is really weird because we're not used to it, but eventually we'll get there. And normally I would never solve the problem like this. I would do it like this instead. But what's going to happen is this log base 2 is going to take out this base 2. So what I'm left with is x minus 1. And then I'm going to realize that this, although I could do it in my head, 2 to the what power makes 4, that's a 2, that I can actually remind you that in the main screen, if you press that math button and scroll up, you can choose this log base. Whoops, but that's not what I put. And that's not what I want. So sorry, I don't know what's going on here. I might have to switch calculators. Okay, put the 2 and put the 4 in, that this is an answer my calculator can give me, and I get 2. So this whole side becomes 2, while this stays 1. And now to solve for x, add 1, and we get the same answer of 3. So this was a lot more work than this, but sometimes you won't have a choice. You're going to have to do this. So let's take a look at this problem and try that as well. So what I need to do, the absolute rule, is isolate the base and the exponent. So I'm going to start working in my order of operations, and I'm going to use addition subtraction to move this 2 over, and when I do, I get 64. So I get right back to here. So this is the other way to solve it. And now what I want to do, there is no multiplication division to move because it's a base and an exponent. So now to undo the exponent, I'm going to make a log. So I go to the exponent side, and since it has a base of 4, I'm going to have my log have a base of 4. So this is undoing the exponent. So I write what's there. And if I log base 4 the left side, I have to log base 4 the right side, and then put the 64. And again, we're going to use this inverse property that says if the base of the log and the base of the exponent are the same, they cancel each other out, and you're left with this. And then you remember, oh, hey, I can go to my calculator and type that in. So you press math, you scroll up, and you put your 4, your arrow over for your 64, or you could use your head. You get 3, so all of this is worth 3. And now to solve for x, I add 3, then I divide by 2, and again, we get the same answer. So that's solving a log problem. So let's try a few more down here. We're not going to go necessarily in the order that they have. So these directions are absolutely the same, okay? They're just going to be phrased differently. So solve, same thing. So we're going to only do the exponent problems here, and we're going to solve them only in this new way. So I need to isolate the base and the exponent. So that means I need to move the 2 and the 1. And again, I'm just going to work backwards in my order of operations. Sorry. So here's my wall. So the first thing I'm going to move is the addition subtraction, not in here because that's part of the exponent. I'll get to that later. So I'm going to add 1. And that gives me 7. And then I'm going to move the multiplication division. That's the 2. The 3 is not part of it. I like to keep this circled because I can't touch anything there. So I'm going to divide by 2. And 7 divided by 2, that's a fraction, but it's also a nice decimal, so I'm just going to make it a decimal. And so now there's no way I can get a common base between 3 and 3.5. You know, 3 and 9, 3 and 27, 3 and 81, but not 3 and 3.5. So I'm going to have to use the log property to get to do this. So since it's an exponent, I'm going to make a log. So I'm going to write the word log first, and you know what? I'm going to go ahead and make the log on the other side. And if this base is 3, this is base is 3, and this is base is 3. And now I'm going to drop everything down, 3 to the x plus 1, and 3.5. And now this log base takes out this log base, and over here, so I'm running out of room, I'm just left with x plus 1. And now I'm going to go to my calculator and type that in. So 3 follow with 3.5. It's going to be a very small number. It's like 1 point something. So 3 decimals. I'm going to write 1.140. So over here I have 1.403. Now I'm just going to keep this in my calculator. I'm just writing down the decimal for showing work. And now to get x alone, I just subtract 1. And so since this is already in my calculator, I'm just going to subtract 1. And now I get 0.140. There you go. Let's do this log problem. The only difference is the base of e, and we'll talk about how you handle that. So again, I'm going to draw my wall. I do have to isolate the base and exponent, so I like to circle them so I know what I want to isolate. And now to get e to the x, I'm going to remove my addition subtraction first, so I'm going to subtract 3. That gives me 8, right? And then keep that circled, and now I'm going to move the 4, multiplication division. I'm going to divide by 4. And now to get to my exponent, where the x is, I'm going to make a log. So when it's e, you're more than welcome to write log still. So log this side, log this side. This is the base, then this has to be the base. And then I'm just going to drop these things down, e to the x and 2. And log e and e cancel each other out. But remember, log e I could have written as ln instead of log e. But I think this is easier since this is new for us. And now I get x, and then here I'm going to type this in. So for sake of easiness, now I do want to remember that log e is ln, and I'll just press ln too. So on any calculator, just press your ln button, press the 2, and I'm going to write 3 numbers behind the decimal. So that is 0.693. And then we're done. Oops, sorry, you couldn't see that. So that is how you solve these exponent problems. All right? So let's see. I think that is all I'm going to do from there for now. And now I want to show you, so what the idea is now, we would actually jump into our packet and we would start practicing some of the solving problems. And you can see that list in Schoology, the problems that we would do. So the second part of the video is how do you solve when it's a log problem. So that's where we're going to pick up now. How do you solve a log problem? And we're going to do this same idea. We're going to show that, if you have a log base and a base of an exponent, they're the same. We cancel them out. So here what we're going to do is we're actually just going to separate and circle the log. So what I need to do is isolate the log. So there's a big difference. I need to grab a pencil here. So in this problem, when I draw my wall, right, like I did here, and then I circle the base and the exponent, here I just want to circle the log, which is this. Now, what would be different, which we're not going to change it, is if this were in parentheses, and then it says the argument is x plus 5, not just x. So then this would be the whole log. So you got to pay attention as to what is part of the argument and what's not part of the argument. But it's just this. So now I'm going to work to get this alone, and then I'll show you how we undo the log. So first move the addition subtraction. I'm going to subtract 5. That gives me a negative 4. And I like to keep this circled the whole way. Now I'll move the multiplication division. I'm going to divide by 2. Okay. And now to undo the log, I'm going to make an exponent. So that means I need to see what the base of my log is. So remember, in ln, it's a base of e. So what I'm going to do is I have to make an exponent now. So here's an exponent with the base of e. Here's an exponent with the base of e. And what's going to happen now is, since I'm making an exponent problem, I actually need an exponent. And that's where this comes in. This becomes the exponent, and this then becomes the exponent. And now, this base e and this base e cancel each other out. And I'm just left with x. And now e to the negative second power, that's just something I type into my calculator. I hit second ln to get that e to appear. I type in a negative 2. And I get my answer, so 3 numbers behind the decimal. And I know this is a little weird, and we'll definitely do some more practice. In class, we would be working on the whiteboards. So actually, this one is, I should have done this one first, so sorry, I should have made another log problem. We're going to make another one here. Actually, let's go up here and do these. Sorry, I totally forgot those. So I can draw my wall. I'm going to circle my log and its argument. That's it. So now what I'm going to do to solve for the log is, here's my order of operations backwards. So I'm going to move my addition subtraction, so I'm going to subtract 1, and that gives me 3. Keep that circled, and now I'm going to move my multiplication division. I'm going to divide by 2, which I'm just going to make the decimal 1 1/2. 3 halves is 1 1/2. And now to undo the log, I'm going to make an exponent. So whatever the base of the log is, it was what the base of the exponent is going to be. So base of 9, base of 9. But it's not an exponent problem unless I have an exponent. So this becomes the exponent, and this becomes the exponent. And again, if the base of the exponent and the base of the log are the same, they cancel each other out. So on this side, I'm just left with x. And now over here, I just have to go to my calculator and type in 9 to the 1 1/2 power, and I get 27. Okay? Let's take a look at this one. So I'm going to circle my log and its argument, which is all of this because of the parentheses. And now, here go my order of operations. First, I'm going to move this subtraction. I'm going to add 6. So I apologize. Find the zeros means it equals 0. Let's back up there. So I'm going to add 6. Keep that circled. Now I'm going to move my multiplication division. I'm going to divide by 3. And now that it's isolated, I'm not keeping it circled. So now what I want to do is to undo the log, I need to make an exponent. And that is determined by the base. So if this has a base of 4, my exponent will have a base of 4. Base 4 this side, base 4 this side. Since it's an exponent problem, I need an exponent. This becomes the exponent. and this becomes the exponent. And now, once the bases are the same, now what I can do is this log base and this log base, this base of 4 and this base of 4 cancel each other out. So here's my, well, on the right side I have x plus 2. On the left side I have 4 to the second power, which I don't need a calculator for. That's 16, and now just subtract the 2, and you get 14. So those are 4 examples of exponent problems, 3 examples of log problems, and you know what? I should have done this one and I totally left it out. So find the zeros, let's do that one. That just means make this equal to 0, and I'm going to start solving for x. So here's my order of operations backwards. And first, here's my base and exponent. I want to isolate that, so I'm going to subtract the 1. That's what this says. There's no multiplication division to move because I've isolated the base and the unit onto log. So remember, I'm going to log this side and I'm going to log this side, right? And then I need a common base, so this determines the base, 3. So log base 3. And now I still need the arguments of the log. So this becomes the argument, and this becomes the argument, like this. All right? You with me? Okay. So log base 3 and exponent base 3 cancel each other out. And now I'm going to go to my calculator. I'm going to try to type this in. So remember, you got to press that math button. You do have to scroll up. Put your 3 in your -1. Oh no, and we get non-real answers. So remember, your argument in a log can never be negative. And this is something I did explain in class that I'm not making a video for. So this side has no solution, which means this whole thing has no solution. All right? So that is the basic gist of solving logs. I think with the video, I'm probably going to get a few more minutes out of this and just take a look at some of these other problems, all right? So let's actually start with these problems down here. I just flipped the page. I'm on page 81. And let's just go over some of the things that we're going to do here, all right? So again, you could see these problems set up. So in some of them we're evaluating, so I just plug the number in, do the math that I can. And then the other one, we're going to be finding the zeros, which means we're going to be solving. So just to review here, I'm going to put 1/2 into my function, right? So 4, and then 1/2 plus 1 minus 2. So I just need to do the math here. So 1/2 plus 1 is 1/2. There's not a lot of room here. Or sorry, 3/2. And then this is just tying some things in from previous chapters. 4 to the 3/2, I hope you remember, you could write that as a radical. You could also type into calculator. And this 2 would become the square root, and the 3 would become the exponent with that minus 2. And what I can do is take the square root of 4, which is 2, and then 2 to the 3rd power is 8, and then subtract 2, and when I'm done, my final answer is 6. Definitely a challenging problem there. So the next one, I'm going to put -1 in. And this just becomes 0. So 4 to the 0 power and then subtract 2. Well, anything to a 0 power is 1. So 1 subtract 2, my final answer here is -1. Now, in the next one, I actually need to find